Isosceles triangles are triangles with two congruent sides. Let's fill that in. Triangles with two congruent sides. We can talk specifically about the names of those sides and the angles that are also associated with the isosceles triangle. The sides that are congruent in an isosceles triangle are called the legs. In the figure to the right, our legs are here and here on the left and the right side of the triangle. The third side of any isosceles triangle, the non-congruent side, is what we call the base. This base happens to be on the bottom, but in any generic isosceles triangle, it's just the side that is not congruent to the others. Now, the angle opposite the base is called the vertex angle, and the angles that are opposite the congruent sides are what we call base angles, and we'll learn in just a moment that those base angles are also congruent. Let's label our triangles. Vertex angle, and then you have base angles here and here. We have a theorem that states if a triangle has two congruent sides, then the angles opposite those sides are congruent. So if two sides of a triangle are congruent, then the angles opposite the sides are congruent. In the triangle pictured below, we can see that RT is congruent to RS, therefore angle T is congruent to angle S. That's our isosceles triangle theorem. The converse of the isosceles triangle theorem states that if two angles of a triangle are congruent, if two angles of a triangle are congruent, then the sides opposite those angles are also congruent. Recall that a converse of a conditional statement is when we reverse our hypothesis and our conclusion. So we can see in the figure that angle N is congruent to angle M, and we can conclude that LN is therefore congruent to LM. We can use these theorems to calculate the measure of angles in triangles. Recall that in a triangle, the sum of the interior angles is 180 degrees. When I look at triangle ABC, I see that side AB is congruent to side AC. Therefore, angle A is congruent to angle C, both of which are missing angles. But since they are congruent angles, we can label them with the same variable. Therefore, the value of x can be calculated by adding the three angles of the triangle, x plus x degrees, plus x degrees, plus 78 degrees is equal to 180 degrees. Combining like terms, 2x plus 78 equals 180. I subtract 78 from both sides. 2x is equal to 102. And when I divide both sides by 2, I'm left with x is equal to 51. If x is equal to 51, then I can conclude that angle C and angle A are both equal to 51 degrees. Pause the video, take a moment, and solve for angle Q in exercise number 2. Now, when I'm solving for more than one variable, again, I want to use the isosceles triangle theorem that states if two sides of a triangle are congruent, then the angles opposite those triangles are also congruent. Therefore, we can conclude without any calculations that angle X or the value of x, is equal to 46, since it's congruent to the 46-degree angle. Angle y, therefore, can be calculated by the equation that tells me that y plus 46 plus 46 is equal to 180 degrees. As angle x down here is 46 degrees, again, we know two angles of the triangle, and we can calculate for the third. So y plus 46 plus 46 equals 180 degrees. Y plus 92 degrees equals 180 degrees. And if I subtract 92 from both sides, we can see that y is equal to 88. Again, pause the video, solve for both variables x and y in exercise number 4. Number 5 is going to require us to write a linear equation and solve for a variable. This is an example of the converse isosceles triangle theorem, where we have two angles congruent, and therefore the sides opposite those angles are also congruent. And that leaves us with an equation that 2x plus 6 is equal to 3x minus 6. As the sides are congruent, we can write an equation that says that their measures are equal. We'll solve this linear equation, subtract 2x from both sides. 6 is equal to x minus 6. From the right, I'll add 6 to both sides, and therefore x is equal to 12. Exercise number 6, again, we have an isosceles triangle, two congruent sides, which tells me that I have two congruent angles. So in solving for x, we have a fairly different strategy than with number 5, because instead of congruent sides, we have congruent angles. Since angle R is congruent to angle Q, we can conclude that angle R has a measure of 2x degrees. And I know that the sum of the interior angles of a triangle is equal to 180 degrees. I'll add the measures of all three angles, set them equal to 180 degrees, and solve for my variable. In combining like terms, 40 plus 4x equals 180 degrees. We'll subtract 40 from both sides. 4x is equal to 140. And divide both sides by 4. X is equal to 35 degrees. For number 7, we're looking at a similar situation to number 6, where I have two sides congruent. Therefore, my base angles, the sides opposite the congruent sides, are congruent. And therefore, this angle at the bottom right, is equal to 2x plus 3 degrees. The marking here tells me that I have a 90-degree angle. And as the sum of the interior angles of a triangle is equal to 180 degrees, I will add the three angle measures, 90 plus 2x plus 3 plus 2x plus 3, and set them equal to 180 degrees. We'll combine like terms to get 4x plus 96 equals 180 degrees. Subtract 96 from both sides. which gives me 4x is equal to 84. Let's bring that up here to show the work. 4x equals 84. And in dividing both sides by 4, I can see that x is equal to 21. All right. Now, for number 8, we've got a lot going on here, but let's notice that our triangle is situated such that the bottom and the left sides are my congruent sides. FE is congruent to FD. Therefore, it's angle D that's congruent to angle E. So in solving for x, we can see that 4x minus 8 is the measure of angle D because D is congruent to E. It happens also that angle F is equal to 4x minus 8, so what we actually have is an equilateral triangle. Let's solve for x. Again, the three angles of a triangle, 4x minus 8 plus 4x minus 8 plus 4x minus 8 have a sum of 180 degrees. We'll combine like terms to get 12x minus 24 is equal to 180. We'll add 24 to both sides. 12x is equal to 204. And when we divide both sides by 12, we can conclude that x is equal to 17. Now, in solving for y, as the two sides of the triangle here are congruent, we can see that 6y plus 3 is equal to 8y minus 5. 6y plus 3 equals 8y minus 5. Let's subtract 6y from both sides. 3 is equal to 2y minus 5. We'll add 5. 8 is equal to 2y. And in dividing both sides by 8, we can conclude that y is equal, we divided both sides by 2, didn't we? Y is equal to 4. And there we go. And then finally, let's take a look at number 9. We're going to solve for each variable. We'll solve for x, and then we are also going to solve for the missing angles, h, j, and g. The isosceles triangle has GJ congruent to GH. Therefore, angle J is congruent to angle H. I don't know the measure of angle G yet. I don't even have an expression for it, so I cannot set the three of them added together to equal 180 yet. What I can do is show that 8x is equal to 6x plus 18. As the two angles are congruent, their measures are equal. So our equation shows those measures equal to one another. Subtract 6 from both sides leaves me with 2x equals 18. And dividing by 2, we can see that x is equal to 9. Therefore, in solving for the measure of the angles, we'll start with h. The expression for h was 8x. X was equal to 9. Therefore, h is equal to 72 degrees. 8 times 9 is 72. We'll do the same for angle J, as we know the expression for J was 6x plus 18. Again, we'll replace x with the value we solved for, which was 9. 6 times 9 is 54. 54 plus 18 is equal to 72. which is exactly what we want, given that this was an isosceles triangle, and our first matter of business was to mark those two angles congruent. So we did the right thing. They're both equal to the 72 degrees. They are congruent to each other. Now, the measure of angle G can be found by recalling that the measure of all three angles, angle G plus angle H plus angle J, are equal to 180 degrees. So the measure of angle G plus 144 degrees is equal to 180 degrees. In subtracting from 144 from both sides, we can conclude that the measure of angle G is equal to 36 degrees.